So starting with rational equations, let's say they've asked us to solve the equation. The question says solve the equation, and we have let's say 2 divided by x minus 1 is equal to 3 divided by, let's say, 2x minus 3. We want to solve this equation. Now such a simple equation, just cross multiply, right? So this 2 is going to multiply what is down here. So we're going to have 2 multiplied by 2x minus 3, and that is going to be equal to, get this 3 on top, multiply with what is down there, 3 multiplied by x minus 1. And this, you are going to have 4x minus 6, giving you 3x minus 3. Take like terms to the same side. I'll take the 3x the other side, so it becomes negative 3x. I'm going to get this negative 6, take it this side, it becomes positive 6. But remember, I've got a negative 3 that side. 4x minus 3x gives us x. 6 minus 3 gives us 3. So this is the answer to this question. Now, rational equations are so simple, and actually they are too simple for a university student. That is why I'm going to concentrate on rational inequalities, because that's the tricky part. That's where people fail, on rational inequalities. Right. So for an equation, you can do the cross multiplication like that, and then you would have found solutions. Now let's talk about rational inequalities. The first one we've been given, solve the inequation 1 divided by x plus 1 is greater than 2 divided by 3 minus x. Now friends, first thing first, for rational inequalities, you are not allowed to cross multiply. Please take note of that. Immediately you do the cross multiplication, you've made a mistake. So solve the inequality 1 over x plus 1 is greater than 2 over 3 minus x. Please take it in mind, you are not allowed to cross multiply for rational inequalities. If it was an equality or an equation, you could cross multiply. So then what do we do? I'm going to get this term, take it this side, right? So that is going to become 1 divided by x plus 1. And then this term will become negative 2 divided by 3 minus x. And that is going to be greater than 0. Okay. After reaching here, now get what is on top of the first fraction, multiply with what is down the second fraction. That is going to give us 3 minus x. Please, this negative belongs to 2. So I'll get this one on top of the second fraction, multiply with what is down the first fraction. So negative 2 times x, that is going to be negative 2x. Negative 2 times 1, that is going to be negative 2. And then divided by, multiply the two denominators. I think this is something that we did in high school. There was a question which used to say merge as a single fraction, always in paper 2 mathematics. So multiply x plus 1 and then 3 minus x. And this is going to be greater than 0. So add like terms. I'll start 3 minus 2. That is going to give us a 1. Negative x minus 2x. That is going to give us a negative 3x. In the denominator, we have got x plus 1 and then 3 minus x. That is greater than 0. So at this point, I would ask people to hear if it is okay, because things start becoming bad like here, from here. Okay, are we okay up to this point? Do we have anyone with a question up to this point? Shekaina, are we okay?
Yes, you're fine.
Do we have any questions? Anyone with a question up to here?
No questions.
All right, good. Now please, from this point, I have said never cross multiply and never do it. So from this point, equate everything you're able to see to 0. So get first the one on top, equate it to 0. So I'm going to say 1 minus 3x is equal to 0. Take the 3x the other side, we're going to get that 1 is equal to 3x. Divide both sides by 3, you're going to find that x is equal to 1 over 3. Okay, also get this term equated to 0. So say 1 plus, that is actually x plus 1, which is the same as 1 plus x, equated to 0. So I'm going to find that x is equal to, take 1 the other side, negative 1. Get also this one equated to 0. So I'm going to find 3 minus x is equal to 0. Take x inside, it becomes positive, right? So that would be positive. X is equal to 3. So you have got these three solutions. Please, guys, take note. Okay, when you find these, what?
Wow.
Yes, please.
The network is poor. I didn't get any of the explanation you just started explaining.
Okay, so
Same me, I didn't get that thing.
you didn't. Is it that the
I
network
didn't
is?
get that explanation.
Is it that the network is cutting, or you didn't understand?
You're too fast.
Or I'm too fast?
Yeah.
No, also the network is cutting some.
Is it for everyone? Is am I cutting for everyone?
Yes.
Like the network is cutting,
Yes.
but how come you are responding so fast? Okay.
Mine is quite good.
Ah, so it means it's not me. If Mr. Richard the network is okay, then it means someone is supposed to be somewhere at the wrong place. Alright, I'm going to repeat what I've just said. So what I'm from mentioning is that don't cross multiply for rational inequalities. Okay, first thing I got this, took it the other side of the equation, it gave us the second stage, which is here. And then what we did is we just merged this as a single fraction. Get what is on top, multiply with what is down, it gives you this part. And then get the negative 2, multiply with what is down here, it gives you this part also. Okay, from there multiply the two denominators also, that is what gives you what is in the denominator here. From there, just simplify. You get the 3, you add with a negative 2, that will give you positive 1. And then negative x minus 2x, it gives you negative 3x. That is what we did. The denominator, just write it the same. Please don't think of crossing and multiplying. No, x times 3, x times x, 1 time. Don't do that. Don't do that. So when you reach here, equate every single term to 0. I got first what was on top, 1 minus 3x. I equated it to 0. I found x to be 1 over 3. I got x plus 1, I equated to 0. I found that x was negative 1. Got the 3 minus x, equated it to 0. I found that x was equal to 3. Are we okay now? Uh,
Yes.
Shekaina, are we okay now?
Yes.
All right. So from here, I hope you people know which number is the smallest. I want Shekaina to say between 1 over 3, negative 1, and positive 3. Which one is the smallest number? Which one is the smallest? No response. Back then, which one is the smallest number here? 1 over 3, negative 1, and positive 3.
-1.
Okay, so please, this thing you are seeing which I've written here is basically a number line. Okay, so I'll put negative 1 here because it's the smallest. The next small number is 1 over 3. And then the next one is positive 3. Please don't confuse them. You start with 3, negative 1. No, write them in ascending order. So if you've just joined, we'll use another example. Don't worry, you're going to understand. Alright. So what I'm going to do is I'm going to get all these factors which I equated to 0. Remember I equated 1 minus 3x to 0, so I'll put it here, 1 minus 3x. We also equated x plus 1 to 0, I put it here, x plus 1. We also equated 3 minus x to 0, I put it here, 3 minus x. Now remember these are multiplying and dividing. Well, when you multiply signs or divide signs, it will be the same, right? So I'll just put q here. If I want, I can put p. So q is just meaning quotient. Quotient like division of signs. Or you can put p, which means product of signs. Now, when we equated 1 minus 3x to 0, we found 1 over 3. Okay, when we equated 1 minus 3x, again, those who've just joined, don't worry, you're going to understand. We are still explaining. So when you when you get 1 minus 3x, you equate it to 0, you're going to find 1 over 3. This is telling you that 1 over 3 is going to be a division of signs for this factor. So what happens if I use values of x greater than 1 over 3? Just think of anything greater than 1 over 3. For example, a 10, 50, 70, or even just a 1 itself is greater than 1 over 3. What happens?
I can't get what you are saying.
Re- is it that you can't understand or you can't get? Paxin,
Starting from the table there.
you can't get or you can't understand.
I can't understand from the table.
Okay, so what I'm saying is just get these factors, this one, and this one. So if you don't understand with this one, don't worry, I'll use another example you get to understand. So just get these same factors, you put them here. Those same ones we equated to 0. Now when we equated 1 minus 3x to 0, we found 1 over x. So what will happen when I use any number of greater than 1? I mean, we found 1 over 3, right? What happens if I get any number greater than 1 over 3? I put in this function. For example, a 2. Put 2 here. 3 times 2 will be 6. 1 minus 6 is negative. Meaning that as long as I get anything above 1 over 3, I put in this function, I'm going to be getting negative. So I'll put negative here. Immediately I cross this 1 over 3. Going the other side, we'll have a positive. If you've just joined again, don't worry, you're going to understand with the next example. When we equated x plus 1 to 0, we found negative 1. Meaning that negative 1 is where signs are going to be changing for this factor. What happens if I use a value greater than negative 1, like a positive 2 or a 0? I put here 0 is greater than negative 1. 0 plus 1, you see that it will be positive. So anything greater than negative 1, I put in this factor, it will be positive. So positive, 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 meaning that immediately I cross negative 1 to be negative. When I equated 3 minus x to 0, I found a positive 3. What happens if I use values of x greater than positive 3? Like a 4, I put here 3 minus 4 to be negative, right? So it will be negative. Immediately I cross this sign because it's what is changing signs for this factor. Then everything else will be positive since above was negative, meaning it to be positive. Now what we are doing here is we are divide. This is quotient, so you look at the division of this sign, positive or just multiplication. Like when you are dividing or multiplying signs, the same. Positive times negative times positive, we know that is going to give us a negative. Positive, 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 negative, 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 positive, negative, positive. Now for this function, we want where it is greater than 0, and numbers which are greater than 0 are positive, meaning that the solutions for this inequality, they will be from here up to here. This is where we're seeing positive values, and then from here going all the way this side. So I'll just put an arrow because all the answers this side. So you look at the quotient, this quotient. So where it is positive, those are the solutions because we are looking for where it is greater than 0. So if it was less than, we would have looked for where it is negative. That would be our solution. So therefore we're going to say that our solution set is going to be equal to, you are seeing we're moving, our solution is from, and I'm not shading these because if I shade, it means this one was greater than or equal to, but it's only greater than. So our answers are from negative 1 to positive 1 over 3. I'm going to use these brackets. These brackets means that these places are open or you are not including those values. And then union means together. We also have this region, we are also including it. So that is from what? Positive 3. Now you can see the arrow is pointed forward. So since it's pointed forward, you just put infinity because you don't know where the arrow ends. So you put a closed bracket there, even a closed bracket here. So this is the solution set for this inequality.